Okay, this video is going to go through the homework assignment on page 291, 15 to 40 all, 45 to 48 all. This video is going to be for only the even problems. There is a separate video for the odd problems. Before we get started, I just want to talk a little bit about indefinite integrals and how I'm going to approach these. You'll notice that number 16 and 17 are already written as polynomials or power rule ready, as we like to say. And if possible, I'm going to try to write all my integrands, all my arguments, the thing I am taking the integral of, as something that I can reverse the power rule. I'm also not going to be checking my result by differentiation because I'm just not, but you probably should. All right, so first off, we have the integral of 5 minus x. That's just going to be 5x, add a power, divide by the new power. We're going from a power of 0 to a power of 1. Divide by the new power minus x. There was a 1 here. I'm going to add a power. I'm going to divide by the new power. I'm going to add a constant at the end because I could have had a constant that I took the derivative of, and then that became 0. And that is my solution for number 16. Number 18, I'm going to start 4x to the third. I'm going to add a power. I'm going to divide by that new power. And then I've got 6x, add a power, divide by the new power, minus 1, and then add a power. And then plus c. And if I took the derivative of this real quick in my head, I would get 4x cubed plus 6x squared minus 1. Okay, so number 20 and 22 are not written power rule ready. So the first thing I'm going to do is I'm going to write this as the integral of x to the 3/4 plus 1 dx. So now when I add a power, I'm going to have x to the, 4/4 plus 3/4 is 7/4. And when I divide by the new power, dividing by 7/4 is like multiplying by 4/7. And then plus 1x plus c. Same thing for 22. I'm going to rewrite that as the integral of x to the -4 dx. I'm going to add a power. So -4 plus 1 is -3. I'm going to divide by the new power. That hurts my eyes. I'm going to make it -1/3. Again, coming up with this idea of, well, I'm not coming up with, applying this idea of writing all my integrands as power rule ready. I'm going to take all my terms in 24 and divide it by x to the 4th. And the reason I can do that is because x to the 4th is a monomial. If this was like x to the 4th plus 1, it would be no bueno. No good, can't do it. But because it's just a monomial, I can divide everything here by x to the 4th. I'm even going to make this number all nice and slow. So it's like we had x squared over x to the 4th plus 2x over x to the 4th minus 3 over x to the 4th. And again, I'm going to write it power rule ready. So I'm going to write it not as 1 over x squared, but as x to the -2 plus 2x to the -3 minus 3x to the -4. Add a power, divide by the new power. Add a power, divide by the new power. Oh, that's right. Add a power, like a little song. Whoops, I forgot to add. Add a power, divide by the new power. So this is going to end up to be -x to the -1 minus x to the -2 plus x to the -3 plus c. Find it, not because you should box your work, just so we can. All right. For 26, before I take the antiderivative, I'm going to multiply this out. So let's write 2t squared minus 1, 2t t squared minus 1. It's going to become 4t to the 4th minus 2t squared minus 2t squared plus 1 becomes the integral of 4t to the 4th minus 4t squared plus 1 dt. Add a power. Divide by the new power. Add a power. Divide by the new power. Oh, shoot, I wrote x. Have it. Easy to find. Okay. 28, same situation. I want to make that power rule ready. So I'm going to distribute that t squared. So I'm going to have the integral of t squared plus 3t cubed dt. I don't like the orange. So add a power, divide by the new power, add a power, divide by the new power, plus c. This is like the best one, guys. It's just going to be 3t plus c. That one's the best. Okay. Now, for number 32, we are going to need to remember our trig derivatives. And so I see I have this minus sine t, and I kind of want to think to myself, what has a derivative of minus sine t? Oh my gosh, you know what it is? It's cosine t. So it's going to just become t to the 3rd over 3 plus cosine t plus c, because t cubed over 3, derivative of that is just t squared, and the derivative of cosine of t is negative sine t. For number 34, people get weirded out because we're like squaring the angle, and then we have plus secant squared. Theta is just the variable. Don't make it so dramatic. Boom. There we go. Now, we have to, again, remember our trig derivatives. What has a derivative of secant squared? I did not need that much space. That is okay. All right, for 36, this is kind of nice because this is just going to become x cubed. X cubed has a derivative of 3x squared. Add a power, divide by the new power. 3 divided by 3 is 1. Now, e to the x. The derivative of e to the x is e to the x. Because just an x there, I don't have to worry. If it was something else, like if I had the derivative of the e to the u, then we'd be worried because it would be e to the u times whatever the derivative of u is. That's a prime. But it's just x. So it's just going to be 2 coefficient e to the x. And this one might be a good one to check with differentiation. So to check it, the derivative is going to be 3x squared. And yeah, that works great. Woohoo! Number 38, we want to distribute because nobody wants to deal with this product. You don't know how to take the integral of a product yet. We'll get there, but we're not there yet. So the first thing we're going to do is we are going to distribute, and we're going to have the integral of secant y tangent y minus secant squared y dy. We got to use our good derivative knowledge because we know what has a derivative of secant tangent. Secant. What has a derivative of secant squared? Tangent. Hooray! Getting a little punchy. All right. I thought there was one on those. Wait, hold on. I feel like we lost one. Oh, yep, there it is. All right, number 40. Number 40, we got to be extra careful because it's very easy to want to split this and make it like cosine over 1 minus cosine over this would be the worst thing in the universe. This is going to land you right here. You know what this is? This is math jail. We can't divide by a binomial like this. Don't do it. Don't do that. Instead, we're going to remember from pre-cal, sine squared x plus cosine squared x equals 1. Remember that guy? Yeah, you do. And that reminds us that sine squared x can equal 1 minus cosine squared x. So we can sub sine squared x into this denominator, which is what we're going to do, because no one wants to deal with the binomial. So now we are going to have the integral of cosine x over sine squared x. And you're thinking, Mrs. Strauss, this is not getting any better. Yes, it is. Have faith. What we can do, because it's multiplication in the denominator and not subtraction, this would be a no. Can't split that. But this, I can split. Here's how we're going to split it. We're going to make it cosine x times 1 over sine x times sine x. So now we have, whoop, I put them in the wrong order. Hold on, erase. Okay, so now what has an integral of cotangent cosecant or cosecant cotangent? Let's think. What has a derivative equal to negative cosecant cotangent? So the derivative of cosecant is negative. I wrote that says cosecant cotangent. When I take the integral of cotangent cosecant, it's going to be negative cosecant plus c. And then when I would take the derivative of negative cosecant, the two negatives would cancel themselves out. Okay, wait, make sure we get finished now. Yep, up to 40. Okay. Now 46. 48. All right. Sketch the graphs of the functions g of x equals f of x plus c for the following c values. All right. So on this, well, this is not so bad. All I have to do for 48.6 is graph. This is really a question. Let me pause. We really assign this? Yes, this is really the assignment. Okay, this is going to be a snap. We're going to graph g of x. We'll use colors. That will make it more beautiful. The square root of x minus 2, and then the square root of x plus 0, and then the square root of x plus 3. We're going to just swooshy this guy in. So here's the plus 0. Check. 1, 2. We'll make that one pink. Swooshy that guy in. Check. Plus 3. We'll do that one in green. 1, 2, 3. I feel like this is a trick. Check. Someone email me if I've done this wrong. Am I misinterpreting this? And then for 48, 1/2 e to the x. Well, e to the x is like an exponential growth, and 1/2 of e to the x is just going to be a slower growth. But e to the x contains the point 0, 1, and then it goes up like this. So that's going to be the graph I use as my parent graph. So let's see. We've got 48 g of x. We got minus 2, plus 0, and plus 3. So here's for the, oh, that's beautiful. check. I'm going to take that point and move it up 1, 2, 3. And now the asymptote here is going to be at 2. Here it was at 0. Check. Now we're going to take this point and move it down 1, 2. And the asymptote, instead of being at 0, is going to be at -2. And there are our family of functions. I probably should have made this one like a little more steeper, like maybe, oh, that's bad. It should have kind of come up like this, but you get the drift. You get the gist. And there are the even numbers from Biltmore. Hope that was helpful.